The questions related to the alkynes in the previous examinations. There is butadiene. This butadiene is undergoing for the two varieties of addition of hydrogens. One is palladium carbon followed by hydrogen followed by heating conditions in presence of palladium carbon followed by addition of hydrogen under heating conditions results one variety of alkene system. Similarly, the same starting material is undergoing reduction with the help of sodium metal followed by liquid ammonia solutions that resulted into another alkene, that is B is the alkene, and here the alkene generated is A is the alkene. In this generated A and B, we have to identify the products first. Then we have to go for the nature of A and B with respect to the solubility, melting point, boiling point, polarity, addition of bromine followed by what? Addition of hydrogen over them. Addition of H2 related reactions related A and B comparison, rates comparison is needed. See, this is Birch reduction condition. In Birch reduction conditions, hydrogens are going to be added from anti-versions that resulted into the formation of what? Trans-2-butene formation takes place. Here hydrogen and the another hydrogen, both whichever are added, they adds from the opposite sides. Similarly, in the first case, hydrogen addition takes place from the same side, that is, these are the hydrogens, and addition takes place in such a way that resulted into the formation of cis-2-butene. This is cis-2-butene and this one is trans-2-butene. These two are said to be what? Geometrical isomers. Here we can claim that A is what? Cis. Cis is A, whereas trans is what? B. Now we will compare the properties related to the polarity, melting, solubility, dipole moment and all other things. Let us go for polarity. Polarity depends on symmetry. The more the symmetric system, the lesser will be the polarity. So therefore trans system is more symmetric in nature. One particular bonds related dipole moment is getting cancelled by the other. So therefore the polarity, that is dipole moment of cis compound, is found to be greater compared to trans. Whereas when polarity is more, then its nature of interaction with the other molecules like solvent molecules with the same other molecules becomes excess in nature. Suppose if I go for the solvent water, water is a polar molecule with respect to the permanent polarity containing molecule, as being A is more polar in nature, it offers stronger interactions. As a result of this, A is getting more solubility compared to B. When solubility is more, its solubility is more implies cis is found to be more amount of cis compound can be getting soluble inside the water. Now let us go for boiling point. Boiling point also depends on polarity. More polar implies how it makes interactions with the solvent molecules. In the same way, one molecule of cis can make good number of interactions with the other cis molecules. So therefore, more intermolecular force of attractions are present in relative to the trans. Hence, the boiling point of cis compound is found to be higher compared to the trans compound. Now let us go for the melting point. Melting point is the point of temperature where the solid material is converted into liquid in state, whereas that depends on the packing, how effectively within the small space the many molecules are adjusted is the deciding factor. That depends on the packing, that is known as packing efficiency. If symmetrical system is there, that is center related symmetry is present, then its packing becomes very nice. So in case of trans compound, trans over trans adjustment will becomes very compact, that is packing becomes very effective in case of trans compound. So therefore within the small space many number of trans molecules can be present compared to cis. If it is trans, suppose some 100 molecules are there, within cis there may be less than 100, like 50 molecules will be present. Packing efficiency will be higher for the trans compound compared to the cis compound. Because of good packing efficiency, it requires what? Higher temperature to be converted to liquid in state. Hence melting point of trans compound is found to be greater. Now addition of hydrogen, let us have a look, then we will jump our discussion to the addition of halogen. Addition of hydrogen, if we go for the addition of hydrogen, hydrogen addition is a cis addition. Hydrogen addition is a syn addition, cis addition. Both hydrogens tries to add to the double bond system from the same side. In whichever alkene system, there of one side, if there is no bigger bulky groups are present, then from that direction addition becomes so prominent. So that is present in case of cis, because this is a small group, this is also small group, these small groups mark not affects a lot. So therefore hydrogen addition from this side becomes very easy. So therefore addition of hydrogen in case of cis is found to be more effective, with more rate it maintains compared to the addition of hydrogen from the trans. Whereas addition of bromine addition is a trans addition, that is anti addition to the double bond from one end one bromine, and to the double bond whatever bromine first is connected towards that, with respect to first bromine addition of another bromine takes place in the opposite side. Thus we need opposite vacancies. Opposite vacancies are present in the trans, this is small group, opposite group is also small group. So therefore as being trans B, in case of B, bromine addition becomes what most effective, that it maintains what higher rate. Thus the comparison related to the 2-butane conversion to two varieties of butenes like cis-2-butene followed by trans-2-butene systems consisting of A and B different varieties of products related comparison study related to the solubility, melting point, boiling point, polarity, that is net dipole moment, addition rate of reaction with respect to addition of hydrogen, rate of reaction with respect to addition of bromine related information in the form of chart. It appears as like this. We are asked to calculate the number of sigma bonds present in the following unsaturated alkane system. The given alkene and the alkyne associated double and the triple bond associated system is consisting of 5 carbons, whereas 1, 2, 3, 4, 4 carbons. 1, 2, 3, 4, 5 carbons. Now we are asked to calculate the number of sigma bonds present in the total compound. Whereas 5 carbons containing system, this carbon is associated with the 4 sigma bonds, whereas this carbon is associated with, after removing this one 2 extra sigma bonds, and this one is associated with 2 extra sigma bonds, this one is associated with 1 sigma bond, this one is also associated with 1 sigma bond. Total number of sigma bonds will becomes equal to 4 plus 2 6, 6 plus 2 8, 8 plus 2 becomes what 10 sigma bonds. It is associated with 10 sigma bonds, because here sp3 hybridization 4 sigma bonds, else this is sp2 hybridization 3 sigma bonds, sp2 hybridization 3 sigma bonds, sp hybridization 2 sigma bonds, sp hybridization 2 sigma bonds. In that way also we can cross calculate sp3 4 plus sp2 3 plus another sp2 3 plus sp2 plus 2, that is 4 plus 3 7, 7 plus 3 10, 10 plus, that is 4 plus 3 7, 7 plus 3 10, 10 plus 2 12, 12 plus 2 14. This 14 minus number of sigma bonds in between the carbon and carbon, they are counted twice with respect to this, with respect to this. So therefore 1 2 3 4, if I subtract 14 minus 4 will reach us as what 10 sigma bonds are present. What is the product of following sequence of reactions and the set of reactions given as, that is a 4 carbon containing linear chain connected with the triple bond, that is 4 plus 2 6 hexavalene. This name of the compound is what hexavalene. Hexavalene is subjected for a set of reagents related reactions, like in the first step it is subjected for butyl lithium reaction, followed by next is, that is C5H11Br, that is 1 bromo pentane is allowed to react after making this one reaction with the butyl lithium. Whatever resultant compound is obtained, that is subjected for the Lindlar's hydrogenation. Then as a result of these sequence of reactions, whatever product is formed, product related information is asked for us. If I write the zigzag format, these are 4 carbons containing system, whereas this 4th carbon is connected with a triple bond containing system having one terminal hydrogen. This is 1 2 3 4 followed by 5 and 6. This is hexavalene 1 2 3 4 5 and 6. This is hexavalene. This is having acidic hydrogen, but it is weak acidic, though it is connected with the sp carbon in presence of strong bases, like one is butyl lithium. Butyl lithium is n-butyl lithium is relatively a strong base, so it abstracts the proton from the terminal acetylenic hydrogen is getting abstracted in the form of proton by the butyl lithium. As a result, it is converted as butane. This lithium transfers to the triple bond system, and so it becomes 1, 2, 3, 4 carbons followed by 5th and 6th carbons containing system is associated with negative charge followed by lithium. Now this will become, it can behave as base, it can behave as nucleophile. Two varieties of possibilities are there, but under these conditions it is allowed to react with a leaving group containing system, that is pentyl bromide system, hence it is acting as what, a nucleophile. So this on reaction with our pentyl bromide system 2 4 followed by 5, here bromine is present, bromine is acting as a leaving group, hence as a nucleophile it makes attacks over the carbon, thereby CBr bond is broken and it is converted to a connectivity between this carbon atom followed by the other carbon atom. These are 6 carbon atoms and these are 5 carbon atoms. In the middle there is a triple bond. Total 11 carbon atoms containing system is present. Thus it results into the formation of, let us feel, this is the reaction. As a result, the product we are writing, one side it is having 5 carbons, 2, 4 and 5 carbon, whereas this 5th carbon is connected with the triple bond containing system. This is triple bond containing system. Remaining 4 carbon atoms, 1, 2, 3, 4 carbon atoms. Like this, total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5 plus 6, 11 carbons containing alkyne system is obtained. On doing Lindlar's hydrogenation, this triple bond system is converted as cis double bond system. Like this, hydrogen is present, like this, hydrogen is present. One side it is having 1, 2, 3, 4 carbon atoms. 1, 2, 3, 4 carbon atoms. Other side it is having 5 carbon atoms. 1, 2, 3, 4, 5 carbon. Like this, alkene system formation takes place as a sequence of reactions like butyl lithium. Butyl lithium is a base. It abstracts the proton from the acetylenic hydrogen, which is terminal hydrogen, and it is converted as nucleophile. Now this nucleophile makes an attack over the alkyl bromide, thus it results into formation of internal alkyne. This alkyne is participated in partial cis hydrogenation in presence of Lindlar's catalyst, thus results into the formation of what, cis alkene system. The next question, question number 85 is, which of the following alkene on ozonolysis followed by reductive ozonolysis followed by reaction with Tollens reagent produces silver mirror? And the list of the alkenes in the form of options are provided for us are of, and the options provided for us in zigzag form, if I wrote, these appears as, this is cyclopropyl system and this is prop-2-ene system connected with the double bond. This is a symmetric system, that is prop-2-ene connected double bond system. This is but2-ine system. This is but2-ine. This is but1-ine systems. For the writing of the corresponding products to identify the primary and the secondary carbons. Suppose here it doesn't have any kind of hydrogen. This is also doesn't have any kind of hydrogen. It is also doesn't have any kind of hydrogens over here, no hydrogens over here, no hydrogens over here. This is, it is having what, hydrogen containing system. If I write the reductive ozonolysis related products as being those of all terminal ends, terminals of the double bond doesn't have any kind of hydrogens, they produce as ketones. On reductive ozonolysis, what they produce as? They produce as ketone system, that is internal carbonyls are provided. In this also they provides what, and ketones, that is internal carbonyl systems are getting generated. Here also, here that is generating carboxylic acid, and here also second molecule of carboxylic acid is going to be generated. But this acid is acetic acid. In this way, if ozonolysis occurs, one is converted as propanoic acid and other is converted as what, formic acid. This is formic acid. As we know, suppose if I focus my attention related to the products formed under first, second, third, fourth options related, these of all are the options related products on ozonolysis, whereas keto compounds are unfit for the Tollens test, hence this does not provide any kind of silver mirror. This also does not provide any kind of silver mirror. This is also ketone system. If aldehyde is there, aldehyde is having a chance to undergo oxidation. As a result of oxidation, it can be converted as terminal acid, that is carboxylic acid functional group. In that reaction, our silver mirror associated silver plus undergoes reduction and it is converted to silver. Metallic silver is obtained at the interior of the test tube. Thus, we can say that it is active towards the tolerance test. But it is keto. Keto doesn't undergoes oxidation because tolerance is a mild oxidizing agent. Similarly, this is an acid, but this acid is consisting more than one carbons. It is also unfit. This is also unfit to participate under tolerance test. So these of all are unfit. If I go for this one, this is also unfit to participate under tolerance. But this is, though it is acid, this is one carbon containing acid, which is known as what? Formic acid. What we can say this one as formic acid or methanoic acid. In this, carbon maintains oxidation number of +2. There is a chance, a special exclusive variety abnormal compound, that is formic acid, in which carbon is maintaining +2 as of its oxidation state. It is having a chance to undergo oxidation. It can increase its oxidation number from +2 to +4. That is, carbon dioxide formation takes place. Suppose in this formation, if it takes the help of silver plus, that silver plus is converted as what? Silver 0. Silver plus undergoes reduction and it is converted to silver 0. Whereas this formic acid undergoes oxidation and it is converted to carbon dioxide. Whatever the silver tolerance test related information, tolerance test related reagents, if I take inside the test tube, to this if formic acid is added, after this reaction, this formic acid is converted as carbon dioxide, whereas silver plus whatever taken silver mirror reagent, now this silver plus is converted as silver 0. Silver 0 is a metal. It is having high density. It comes to the bottom. At the bottom, it takes the help of surface of the test tube. So therefore, at the interior of the test tube, silver as a layer with uniform layer, silver with some uniform minimum layer, it stabilizes, it stagnates over the interior parts of the test tube. It shines just like a mirror. Hence, this is said to be what? Silver mirror. Hence, the compound of the given options of the alkenes which is eligible to show, alkynes which is eligible to show that silver mirror test is originally where from it is generated? 1-butene. Yes, this is 1-butene. This 1-butene ozmolysis produces, one is methanoic, that is propanoic acid followed by formic acid. This generated formic acid is on reaction with tolerance test undergoes oxidation and reduces the corresponding silver plus present in the tolerance reagent and converts that one to silver 0. Silver 0 is a metal having higher density, stabilizes at the interior of the test tube's surface and appears in the form of a mirror. Hence, this test is known as silver mirror. Hence, that silver mirror active alkyne is 1-butene, that is terminal alkynes are eligible to show the silver mirror test on reaction with whom? Ozmolysis followed by silver mirror test.